Hi, my name is Justine Harkness, and in this video, we'll look at how to write a KEQ expression when we have a reaction that contains either solids or pure liquids. When we are writing a KEQ expression, we do not include pure liquids or pure solids. And let's think about why. The KEQ expression is the concentration of products over the concentration of reactants. And in order to have a concentration, you have to be a solution. So we can have gases dissolve in other gases, we can have gases dissolved in liquids, we can have solids dissolved in liquids. That's why we include things that are gaseous and things that are aqueous. But if we have a pure solid, it's not dissolved in anything. If we have a pure liquid, it's also not dissolved in anything. So pure liquids and pure solids are not solutions. And that is why we do not include them in the KEQ expression. So let's take a look at some reactions and write some equilibrium expressions. So here in part A, we have hydrochloric acid, which is aqueous, reacting with water. Note that water is a liquid, pure liquid, so we can ignore this as we write our equilibrium expression. We have hydronium, which is aqueous, and chloride, which is also aqueous. So as we write our equilibrium constant expression, we'll do the ratio of products. So we have H3O+, we have chloride, and we'll just be dividing this by the concentration of hydrochloric acid. Note that this is the equilibrium expression for an acid reacting with water. This KEQ is sometimes also referred to as a Ka for an acid dissociation constant. And this is something that will be covered in future videos. Now let's take a look at part B. So here we have this calcium phosphate. Notice it is a solid, so we ignore it when we write our equilibrium expression. We have calcium, which is aqueous, phosphate, which is aqueous, so we will include both of our products. So let's write out our KEQ expression. So we have calcium as a product. Notice we have 3 of them, so we'd have 3 as our exponent. We have phosphate. And we also have 2 phosphates, so 2 would be our exponent. Notice there's nothing to put in the reactants since our calcium phosphate is a solid. So this would not have a denominator. So you can see equilibrium constant expressions that have numerators but no denominators. And this particular type of an equilibrium constant expression, where we're looking at the dissociation of a solid, is called a KSP, and we'll look at that in later videos when we get into solution equilibrium. So now you should feel more comfortable writing equilibrium expressions when you have reactions that contain solids and pure liquids.